Welcome to this beginner-friendly comparison for data engineers. If you're just starting out in the world of big data, you might find yourself confused by the many terms that come up together: RDD, DataFrame, Dataset, Parquet, Delta Lake, and Apache Iceberg. These names often appear in discussions about data processing and storage, but they aren't all the same kind of technology. Understanding the differences between them can help you make better decisions when working on data projects. On one side, you'll find Spark's processing APIs, which are the tools we use to tell Spark how to handle data. At the lowest level, there's RDD, which stands for Resilient Distributed Dataset. This is a foundational structure in Spark that gives you a lot of control over how data is processed, but it also requires more manual work compared to other options. Then there's DataFrame, which is the most commonly used API in Spark for ETL, extract, transform, load processes, and analytics. It works like a distributed table with columns and a defined schema, making it easier to work with structured data. For developers who prefer strong typing and compile time checks, especially in Scala and Java, there's the Dataset API. It offers the benefits of both DataFrame and RDD, combining type safety with performance. On the other side of the spectrum, we have the storage and table layers in a data lake. These are the ways data is stored and managed rather than how it's processed. One of the most popular formats is Parquet, a columnar file format known for its efficiency in storage and fast analytical reads. It's widely used because it's portable and compatible with many systems. Delta Lake is another important component. Built on top of Parquet, it adds features like ACID transactions, time travel, and versioning, making it ideal for managing reliable and consistent data in a Lakehouse environment. Similarly, Apache Iceberg is a table format designed to work across multiple engines such as Spark, Trino, Flink, Presto, and others. It provides robust metadata management and scalability, making it a good choice for large-scale data lakes. So the first key idea to remember is that RDD, DataFrame, and Dataset are all about processing data within Spark. Meanwhile, Parquet, Delta Lake, and Iceberg focus on how data is stored and managed in the Lakehouse. A simple rule of thumb can guide your choices. Use DataFrame for most Spark ETL and analytics tasks. Use Parquet when you need simple, efficient, and portable files. And choose Delta Lake or Iceberg when your data lake requires reliable and managed tables. This video will walk through each of these technologies step by step, helping you understand their strengths and when to use them. By the end, you'll have a clearer picture of how to select the right tool for your specific data needs. Now let us start with RDD. RDD means Resilient Distributed Dataset. It is one of the original and lowest level abstractions in Apache Spark. You can think of an RDD as a distributed collection of objects. The data is split into partitions, and those partitions are processed across different nodes in the Spark cluster. In the center of the slide, you can see the idea clearly. Records are distributed into partitions. Spark creates tasks for those partitions, and those tasks run across cluster nodes. RDDs are powerful because they give you fine-grained control. You can use operations like map, filter, flat map, reduce, and many other functional transformations. This is useful when you need custom low-level logic, or when your transformation does not fit naturally into SQL or DataFrame operations. For example, if you are working with very custom objects, complex parsing, or special partition-level behavior, RDDs can still be useful, but RDDs also have important trade-offs. They do not have automatic query optimization like DataFrames. Spark does not understand the structure of the data as deeply because there is no schema awareness like in a DataFrame. The code is usually more verbose, and it is less convenient for structured data. For most modern Spark ETL pipelines, RDDs are not the first option anymore. The practical recommendation is choose RDD only when you really need low-level control. For beginners, RDDs are still important because they help you understand how Spark works internally: partitions, tasks, distributed execution, and fault tolerance. But for production analytics work, you will usually start with DataFrames. Now let us talk about DataFrame. For most data engineers working with Spark, DataFrame is the default choice. A DataFrame is like a distributed table that allows you to work with structured data in a more intuitive way. It has rows, named columns, and a schema, which makes it very natural for tasks like ETL, analytics, joins, aggregations, filters, and SQL-style transformations. When you're dealing with large datasets, this structure helps keep things organized and manageable. In the center of the slide, you can see the flow. We start with structured data, like a table with columns such as ID, name, category, amount, and timestamp. Then Spark SQL parses and analyzes the query or transformation. After that, the Catalyst optimizer creates an optimized logical and physical plan. Finally, Spark executes the plan efficiently using the Tungsten execution engine and whole stage code generation. This is why DataFrames are so popular. They are easier to read and write than RDDs. They are optimized by Spark, which means they handle performance automatically. They work very well with SQL, making them a great fit for those who are familiar with database queries. And they are excellent for common data engineering tasks such as reading files, cleaning data, joining tables, aggregating metrics, and loading curated datasets. In PySpark, DataFrame is especially important because the Dataset API is not commonly used in the same way as in Scala or Java. While datasets offer type safety, they are often more complex to use. But DataFrames also have trade-offs. Rows are not strongly typed at compile time, which means that some errors, like wrong column names or wrong data types, may appear at runtime. This can lead to unexpected issues if not handled carefully. Also, DataFrames give less low-level control than RDDs. If you need fine-grained manipulation of data, RDDs might be a better option. And if your business logic is based on complex custom objects, DataFrame code may feel less natural. Even with these trade-offs, DataFrame is still the best default for most teams. The rule of thumb is simple. Start with DataFrame unless you have a strong reason not to. If you are building Spark pipelines, batch ETL, analytics jobs, or SQL-heavy transformations, DataFrame should usually be your first option. It's a powerful and flexible tool that simplifies many aspects of data processing. Next, let us explain Dataset. Dataset is a typed Spark API mainly used in Scala and Java. The big idea behind Dataset is to combine the benefits of structured data with compile-time type safety. In the center of the slide, you can see the flow. You start with business objects such as a Scala case class or a Java POJO. Then Spark uses an encoder. The encoder converts objects into Spark's internal row format, and it also helps with schema and serialization. After that, Spark executes the job in a distributed way. The key benefit is type safety. With Dataset, some errors can be caught at compile time instead of runtime. For example, if your code expects a specific typed field and you use it incorrectly, the compiler may help you detect the problem earlier. This can be valuable for Scala or Java teams that want to model business logic using typed domain objects. Datasets are also expressive when you want your transformations to feel closer to normal application code. However, there are trade-offs. Dataset is mostly relevant outside PySpark. In Python, DataFrames are the standard API. Dataset can also introduce more complexity than a normal data frame. And for typical ETL workloads, the extra type safety may not be necessary. That is why the slide says, for most teams, DataFrame is simpler. Dataset is mainly valuable in Scala or Java projects where typed APIs give real value. The rule of thumb is, use Dataset when typed APIs give your Scala or Java project real value. For many data engineers, especially those using PySpark, it is enough to understand what Dataset is, but DataFrame will be the everyday tool. Now let us move from Spark processing APIs to storage. Apache Parquet is not a Spark API. Parquet is an open columnar file format. It is designed to store data efficiently for analytics. In the center of the slide, the data is stored by columns. Instead of storing each complete row together, Parquet groups values by column like user ID, event time, country, and revenue. This is very powerful for analytical workloads. Imagine your query only needs the country and revenue columns. With a columnar format, the engine can read only those needed columns instead of scanning everything. That means less data read from storage, better compression, and faster queries. This is why Parquet is widely used in data lakes and lakehouse architectures. It is efficient, it is portable, and it is supported by many tools and engines, including Spark, Hive, Trino, Presto, Flink, DuckDB, and many others. Parquet is excellent when you need simple data exchange and storage. It is also great for read-heavy analytical datasets. However, Parquet by itself is only a file format. It is not a full table management layer. It does not provide ACID transactions by itself. It does not automatically manage updates, deletes, schema evolution, or table versions as a complete table system. If you only write raw Parquet files, handling updates and deletes can become complicated. This is why tools like Delta Lake and Apache Iceberg exist. They often use Parquet data files underneath, but they add a table layer with metadata and reliability. The rule of thumb is, use Parquet when you want simple, efficient, portable files. If your use case is mostly reading and sharing analytical data sets, Parquet is a great choice. Now let us talk about Delta Lake. Delta Lake is a reliable table layer built on top of Parquet. It serves as a powerful solution for managing large-scale data in a structured and efficient way. A simple way to understand it is, Delta Lake equals Parquet data files plus a transaction log. This combination allows for more advanced features that are essential in modern data processing environments. In the center of the slide, you can see Parquet files on the left and the transaction log on the right. The Parquet files contain the actual data organized in a columnar format that is optimized for performance and storage efficiency. The transaction log records what happened to the table over time. This log is what allows Delta Lake to provide important table features such as version control, data consistency, and crash recovery. One major capability is ACID transactions. This means your writes can be reliable and consistent even when multiple jobs are reading and writing data at the same time. This ensures that your data remains accurate and up to date, no matter how complex the operations get. Delta Lake also supports time travel and versioning. That means you can query an older version of a table or recover from a bad write, which is especially useful in production environments where mistakes can have serious consequences. It also supports operations like merge, upsert, delete, and schema evolution. These features are extremely useful in production ETL processes. For example, if you are building slowly changing dimensions, CDC pipelines, incremental loads, or data quality workflows, Delta Lake can simplify the architecture by providing a more robust and flexible foundation. Delta Lake is especially popular in Spark and Databricks environments. It works well for both batch and streaming workloads, making it a versatile choice for organizations that rely on real-time data processing. It helps teams manage Lakehouse tables with better reliability than raw files alone. By adding structure and governance, Delta Lake makes it easier to maintain data integrity and improve overall system performance. But there is also a practical consideration. Delta Lake is strongest when Spark is central to your platform. It can work with other engines too, but its strongest adoption and user experience are usually in Spark-centric Lakehouse ecosystems. The rule of thumb is, choose Delta Lake when Spark is central and you need dependable managed tables. Think of Delta Lake as Parquet plus reliability and table intelligence. It's not just about storing data, it's about managing it effectively and efficiently in a way that supports complex analytics and business needs. Now let us compare that with Apache Iceberg. Apache Iceberg is an open table format built for large analytic datasets and multi-engine lakehouses. Like Delta Lake, Iceberg is a table layer, not just a file format. It manages metadata, snapshots, schema evolution, partition evolution, and time travel. But one of the biggest strengths of Iceberg is interoperability. In the center of the slide, you can see one Iceberg table connected to multiple engines. Spark can use it, Trino can use it, Flink can use it, other query engines can also connect to it. This makes Iceberg very attractive for open data lake architectures where you do not want the table format to depend too much on one processing engine or one vendor. Iceberg uses rich metadata and snapshots to manage table state. It supports snapshot-based isolation and time travel. It also supports hidden partitioning. Hidden partitioning means users can query data without needing to know the exact physical partition layout. This can make tables easier and safer to use. Iceberg also supports schema and partition evolution, which is important when datasets grow and business requirements change. Teams like Iceberg because it is open, scalable, and engine-friendly. It is a strong choice for large shared data platforms where different teams may use different engines. The rule of thumb is, choose Iceberg when interoperability across multiple engines matters most. Think of Iceberg as an open, engine-friendly table layer for the modern data lake. Let us finish with a practical decision guide. First, remember the difference between processing APIs and storage or table layers. RDD, DataFrame, and Dataset are processing APIs. They describe how you work with data in Spark. Parquet, Delta Lake, and Iceberg are storage or table technologies. They describe how data is stored, organized, versioned, and managed in the data lake. For Spark processing, here's the recommendation. Use RDD when you need low-level control and custom logic. But do not use RDD as your default for normal ETL. Use DataFrame as your default choice for ETL, SQL, and analytics. DataFrame gives a great balance of simplicity, performance, and optimization. Use Dataset when you are working in Scala or Java, and typed domain models give your project real value. Now for storage and table layers. Use Parquet when you need simple, efficient, portable columnar files. Parquet is excellent for read-heavy datasets and data exchange. Use Delta Lake when you need reliable managed tables in a Spark-centered or Databricks-centered lakehouse. It is especially useful for production ETL, updates, deletes, merges, CDC, time travel, and streaming pipelines. Use Apache Iceberg when you need an open table format that works across multiple engines. It is a great fit when Spark, Trino, Flink, Presto, or other query engines need to share the same lakehouse data. So the final recommendation is use DataFrame by default. Use Parquet for simple files. Use Delta Lake for Spark-centered managed tables. Use Iceberg for open multi-engine lakehouses. If you remember only one thing from this video, remember this. DataFrame is how you process most data in Spark. Parquet is how you store efficient analytical files. Delta Lake and Iceberg are how you turn raw files into reliable lakehouse tables. That is the practical way to choose between them as a data engineer.